Alright, I'll guide you through what a single linked list is, how it works, and how to implement and demonstrate it in a Java graphic user interface application. So basically, a single linked list is a linear data structure made of nodes so that each node stores data and a reference to the next node, which can also be called a pointer. The list is accessed from a single entry point called the head and ends when a node's next pointer is null. This structure supports efficient insertions and deletions at known positions, but requires traversal from the head to access arbitrary elements. To explain it in a different way, the data is stored in the random access memory in the computer, but is stored in different positions, not in a sequential or adjacent order. That's why it implements the pointers to point where the next node is located in the memory. We're gonna visually see how a single linked list looks like. Okay, so here we have a single linked list. This is pretty much a graphic representation of it. We can see that this list is made of nodes, where each node has a data part and also a pointer to the next node. We can see that, for example, this piece over here is a node. In this case, since this one is the first one in the list, this one would be considered the head of the linked list. Each node is going to have a data part and a pointer. So as this linked list is stored in the random access memory or the RAM memory, the pointer is going to be the one pointing to the next location in the memory. So here we have the node, this is going to be the head, this is going to be the next node, and this is going to be pretty much the tail of the linked list. The last one is going to point to null value because it's the last one. There is no other node to point to, so that's going to end with a null value. Let's go ahead and review the code together. This code implements a simple single linked list model and a swing graphic user interface that registers themes with unique random IDs and displays the list in a table. So I'm going to explain the important classes, methods, and the key behaviors. We can see at first that there are two classes, a node class and a single linked list class. So the first class is gonna be the node class that defines the element as the building block, and the single linked list class manages those nodes and the list as a whole. The node holds the data and the pointer to the next node. The list class holds the head, size, and methods that operate on nodes. Okay, so descending in the code and to explain a bit more how the linked list is ordering by descending order, we can focus on this piece of code. What is the method insert descending actually doing? Well, it puts a new node into the list so the IDs stay in descending order, largest ID first, for example. So let's think of a short analogy. Think of a line of people sorted by height, where the tallest guy would be at the front. Then, when a new person arrives, you put them at the front if they are taller than everyone. Otherwise, walk down the line until you find the right spot and insert them there. Another example of understanding this data sorting implementation would be like this. For example, empty list. If there are no nodes yet, then the new node becomes the head. Bigger than head. If the new node's ID is larger than the current head's ID, put the new node in front and make it the head. Otherwise, walk through the list until you find the first node whose ID is smaller than the new node's ID. then insert the new node right before that smaller node, so it stays after all nodes with equal or larger IDs. And then update size. After inserting, increase the list size by 1. Let me show you what it looks like in a more visual way. Okay, so here we can see an example as if the linked list already had some data previously inserted. For example, we have the current IDs as 90, 70, and 50. So if we try to insert the number 80, what this algorithm would do is to walk past 90, stop before 70, and that's going to give us a new result as 90, 80, 70, and 50. We can see it on the left hand side that we can see, for example, we will fall under the third implementation of this else, of this insert descending method. As you can see, the first one says that if the head is null, then that would be the new head if we inserted a new node. The second else if would actually compare if the new node ID is greater than the head ID, then that's gonna become the new head. However, because we have some values, one in the front and one next to it, then we would fall under the third else clause. Because we need to find the insertion point, so that's gonna compare, that's gonna loop through the values to find and see if the current value is not null, and if the current ID is greater than the new node ID, then assign the current value to the previous one, and the current next node assign it to the current one, and it's gonna insert it between the previous and the current, which is what pretty much happened here with this number 80. We can also see that if we try to insert the number 95, that 95 we can see is greater than the original 90 that we already have in our existing linked list. So that 95 is gonna actually go to the front. It's gonna sort the data in descending order as 95, 90, 70, and 50. This implementation here that we just saw with the number 95 actually falls in the second else if clause, where it says the new node, if the new node ID is greater than the head ID, then that's gonna become the new head. That new node is gonna become the new head, and it's gonna insert it. Let's go ahead and see how this program actually works implementing the graphical user interface. Okay, let's go ahead and run this program to see how it actually works. Okay, so here we can see the graphic user interface. It's going to allow us to enter the team names, and let's remember that the program is going to be auto-assigning unique IDs between numbers 1 and 999 randomly, and it's also going to, for each node that is being inserted, it's going to sort them in a descending order. Let's test it out. Let's enter, let's do country names for team names. So let's do Canada, register. The program has successfully assigned the number 343. Let's do another country, Mexico, register, 426. Let's do France, 639. Let's do USA, 947, and let's do Germany. That would be number 34. Let's go ahead and see if the linked list has been successfully implemented and the insert descending method is also working as it should. List teams. Okay, perfect. Yeah, here we can see it. So now we can see the data that has been sorted in descending order, starting from the number 947 as the greatest number. Then we go down to 639, 426, 343, and then the number 34 as the lowest number. Okay, so we learned about the node class, the single linked list class, how the data structure works, the insert descending algorithm, and how the program runs through the graphic user interface. We even reviewed the code together. So thank you very much for watching.